Welcome to another video from explainingcomputers.com. This time we're going to take a look at this, the NVIDIA Jetson Nano Developer Kit. The computer in this box has got a very powerful GPU with 128 CUDA cores, and it's primarily intended as an artificial intelligence platform. This said, there are potentially lots of other applications for this small board, so let's go and take a closer look. So, here we have the Jetson Nano, the latest addition to NVIDIA's range of Jetson hardware for developing and deploying artificial intelligence. And right now, other boards in the Jetson range cost between about $300 and $1,100. But what we've got here, the Jetson Nano Developer Kit, this costs $99 or £95 or about €90. So this, as NVIDIA claim, is all about bringing the power of modern AI to millions of devices and individual makers. So let's get inside. I think we've just got to cut a few bits of tape, bring in a Stanley with a knife, it will get us through there at the top and again down the bottom, and now hopefully we get it the right way up, it'll just slide. Oh, it will, there we are. Oh look, black packet, and this presumably must contain the board, and there's also in here, look, a little card, little quick start guide. I understand that this is a little stand which folds up so you can put the thing on a stand in that box. Don't think I'm going to be doing that. So let's turn to the board itself. Attention, oh there we are, have to get inside here. Oh, straight open, that was a good noise, wasn't it? And inside here we will find, hopefully in a second, rustle, there we are, there is the Jetson Nano. And this is actually a dual configuration. This is actually a SOM, a system on a module, which slots into a carrier board. And as you can see, the whole thing is pre-assembled. So what I'm going to do is to take it apart so we can look at the two individual parts separately. And here we have the SOM, the system on a module. This is the actual Jetson Nano itself, and it's only 70 by 45 millimeters. And as you can see, it's dominated by this rather large heatsink. And beneath the heatsink, we've got a quad-core ARM Cortex A57 CPU running at 1.43 GHz, and we've got an NVIDIA Maxwell GPU with its 128 CUDA cores. And I'd note that this board can decode H.264 and H.265 video at up to 4K 60 frames a second, and it can encode H.264 and H.265 video at up to 4K 30 frames a second. So there are video recording possibilities with this board. We've also got on here 4 GB of 64-bit low-power DDR4 memory, LPDDR4 RAM, and if we turn the thing over, underneath, in fact, it's far more exciting. You can see the mount for the heatsink and things there. And you can also see here we've got a microSD card slot. And the board will need a microSD card of at least 16 GB capacity to take its operating system. It'll boot from this card. And it's worth pointing out that there are two different versions of the Jetson Nano. The one we've got here is the one that comes in the developer kit. This doesn't have any onboard storage. But there's also another version which comes separately, which costs $129, and that has got 16 GB of eMMC flash storage. But here we have to use an SD card for the storage. So we'll just turn it back again so we can see back to the top. I'd point out that the heatsink, clearly this gives us passive cooling. This heatsink is rated to actually radiate up to 10 watts of module power in a 25 degrees ambient situation. But you can add a fan on the top. You can see the actual holes for that. And there is a connection on the carrier board to actually have a temperature controlled fan. Now, talking of the carrier board, you can see the thing connects to it with the edge connector down here. If you're thinking this looks like a 260-pin edge connector on a standard DDR4 SODIMM module, it does. It's exactly the connector it uses. That's how it connects to the carrier board. So let's now have a look at the carrier board. And here it is. And the first thing to strike me about this board when I actually had it in my hand, when I got it out the packet, is the build quality. This hardware seems really well put together. It really inspires confidence. So let's take a look at the features of the carrier board. If I just to swizz it round like that, first of all, you can take a better look at the slot into which the SOM, the Jetson Nano itself, will slot in. And you'll also see here we've got an M.2 connector. And this is an E-keyed M.2 connector for taking a wireless card. And the interfaces here are a PCIe, USB 2, UART, I2S and an I2C. And I'd note There's no wireless networking on the board itself. You haven't got Wi-Fi or Bluetooth on this board, so you'll have to add a card into that slot to get wireless networking if you want it. If I just turn the thing over, you can just have a look underneath. There we are. There's not a lot to see under the board, but I just thought I'd show you for full disclosure, as it were, all very nicely labelled. And if we flick it back the other way, we should maybe take a look at the top left edge of the board. And here we can find lots of exciting and useful things, and specifically this serial or UART connector, this set of button headers, so you can add a reset switch or a power switch by using these pins. And then we've got a CSI camera connector, and this can actually use a Raspberry Pi camera module. A Raspberry Pi camera module version 2 will actually work on that connector. And cameras are very important for this board because one of the things that the Jetson Nano will be really good at is vision recognition. And then finally here we've got a power selection jumper, and that enables us to use different means of a power input, as we'll see in a second. If we turn to the right edge, you'll see we've got a 4-pin fan connector, a temperature controlled fan connector, and also a 4-pin PoE connector, power over Ethernet connector. And then we've also got here a 40-pin GPIO connector, and this GPIO connector is Raspberry Pi compatible. And you can also use the 5-volt pins on this GPIO connector to actually power the board. And talking of power, if we turn to the long edge, you'll see we've got power connectors at each end. We've got a micro USB power connector here for a 5-volt 2-amp supply, or at the other end we've got a barrel jack for 5-volt supply at up to 4 amps. And you can select which of these you use using the power selection jumper we looked at earlier. In terms of the board's power consumption, I would note that the Nano board itself, a Jetson Nano, is rated at between about 5 and 10 watts, which means it draws up to about 2 amps. And the carrier board also requires between about 0.5 and 1.25 watts itself. So we're getting up towards a good 2 amps of use with nothing connected to the board, which is why you might want to use more than the micro USB power for actually powering the board. Also here on this edge, as you can see, we've got our Gigabit Ethernet. We've got 4 USB 3 sockets as well, and we've got 2 connectors for a monitor, both an HDMI connector and a DisplayPort connector, and these can both support 4K output, and you can use them both simultaneously. You can run 2 4K displays from this board. So there we are. We've now looked at the Jetson Nano SOM itself and its carrier board, so I think it's now high time to put them back together, so we will do that. I think it should just slot in nice and simply like this, just like a sewed-in module, and clicks into place. That's very good. And there's a couple of screws to go in here, so I'll just put the screws in. And all is well. So with the board now raring to go, I think it's high time we went in search of some software. NVIDIA provides some great online instructions for setting up the Jetson Nano, including an extensive PDF user guide and a freely downloadable software development kit, or SDK, called JetPack. This includes a desktop operating system derived from Ubuntu, along with various libraries and APIs, developer tools and demos. The JetPack download is 5.3 gigabytes, and when you've downloaded it, you need to write it to a microSD card using a package such as Etcher. When that's completed, the microSD card slots very nicely into the Jetson Nano. You'll be pleased to know it's a spring-loaded slot, and the card ends up flush with the end of the board. So, with that in place, we can now connect everything up, and here we are, all raring to go. You'll see that I've put the Jetson Nano on some standoffs, which just hold it off the table quite nicely. NVIDIA seemed very keen you should do that. I actually borrowed these standoffs from the Rasp Pi V2 I was looking at recently. And I'm using a microSD power supply, as you can see, not the barrel jack, but I'm using my Yukon microSD power supply, which actually gives up to a 5 volts at 3 amps. This is specifically designed to run higher power single board computers, like, for example, the Tinkerboard S. So hopefully it'll run fine running this Jetson Nano. So let's take this and put it into a socket over here, and there we are. And I'll flick the button. Is there a power LED? Yes, there is. You might just be able to see it down there. So the board is now booting up, so we can now try out the JetPack software. So here we are on the desktop in JetPack, which, as you can see, is a standard Ubuntu desktop. And since I spoke to you last, I have added an Ethernet lead to my setup so I could get online. That seemed a reasonable thing to do. And what you're seeing here is exactly what you get when you first install JetPack. The only changes I've made are to do a bit of scaling and to change the display adapter settings so I can record things properly for you in this video. And as you can see, we've got things like LibreOffice pre-installed. I'm sure this board is not intended for word processing, but LibreOffice is there, and we can go hello, and we can change the hello to be nice and big. This is something I think you have to do on a new computer. Yes, we can say hello, things are working fine like that, and we'll get rid of that. We don't need that. We've got the Chromium browser pre-installed, which is good to see, and seems to work fine. We can go to, say, a website. That's fine. We can look up single board computers and find out about them. All that sort of stuff works absolutely fine. We can go to YouTube, which is always a good test of a browser. So let's go to a YouTube clip here. This is my sample 1080p clip to play on YouTube. Let's just bring up Stats for Nerds, and you'll see it's not perfect. There are some dropped frames here, and I've tried using this with both H.264 if I turned on and turned off, but you still get a few drop frames. But YouTube playback is perfectly reasonable. That said, I'm sure lots of you are going, Chris, the purpose of this board is not to basically play YouTube things and to use a word processor. This board is basically here because it's got the powerful GPU for doing things like AI. And I'm not going to be testing out anything to do with AI in this video because I'll make some follow-up videos using the Jetson Nano looking at various AI stuff. But I am going to show you a few demos of the power of the GPU here. I've got a little terminal window open there, and I've built up some of the CUDA samples that are supplied with JetPack. If I just list what's there, you'll see there's lots and lots of sample files that you can build. You do have to do the building yourself in the terminal. You do have to be quite Linux literate to use some of this stuff. But if I just show you what some of these things can do, there's one here if I've got it somewhere. Where's it gone? That's the one, Ocean FFT. This is an ocean surface simulator, and this is quite nice. So there we are, the little GPU is doing some work there. I think we can zoom in with the mouse. There we are, and I'm quite impressed with that. I don't think you would do that on a Raspberry Pi, so that's quite impressive. And we just close that down. And the other one I really like is the somewhere down here I've got smoke particles, and this is clearly simulating smoke. It's got volumetric shadows. Again, let's make that full screen, which is probably unkind to it. But I think this is really cool. And if I press the right key here, I can pick up the light. And if I got that right, try that again. And where's the light gone? There we are. I can actually move the light around. So the volumetric shadows are moving there in real time. And I'm sure some of you are saying, well, the frame rate isn't brilliant. But actually, for this to be running on a small quad-core ARM board is, I think, amazing. And it's really cool effects. I can press the one key there and put a big block of smoke in, and it'll all wander around like that. I could play with this thing all day. This is a really powerful example of the GPU on the Jetson Nano. The Jetson Nano is an exciting piece of hardware that brings something different to the small computer maker space. On their website, NVIDIA also provide a range of resources for those wishing to develop Jetson AI applications. Personally, I find this particularly useful as one of my goals for 2019 is to develop my hands-on AI skills. And so in my next Jetson Nano video, I'll be experimenting with some of these tutorials. But now that's it for another video. If you enjoyed what you see today, please press that like button. If you haven't subscribed, please subscribe, and I hope to talk to you again very soon.